Good afternoon, friends. Thank you very much. I think it's a privilege to be talking before an audience which is highly technical and on a subject which I don't think I have too much of knowledge about, Defense and aerosupply is a very niche area, and we in technology side very often do not get to speak to an audience who has been in this sector for a long while. Having said that, I think there is a tremendous and a very strong linkage between technology and defense and aerosupply, increasing by the day. Today, more than 50% of what goes in defense is electronics, and this linkage is what we hope to see to leverage with respect to promotion of the electronics sector in the country. We have a series of policy initiatives, Madhav mentioned a few of them, by which we make it attractive for people to do electronics design and manufacturing in the country. There are a lot of initiatives which have been taken as part of Make in India in Defense, and these initiatives added on to the incentives that Department of Electronics and IT is giving, I think it becomes a fairly attractive package. He mentioned about Moore's law and a general school of thought which says that we are possibly ending towards, or we are nearing to the end of Moore's law. We are reaching physical limits where there is a feeling that you're already at 14 nanometer going down to 11, 10, 8, how far can we go? And beyond that, finally it's going to be light. One of the important things that has happened, whether Moore's law stops and we go to light or we go to some other technology, one of the most important things that has borne steadfastly over the last 2 to 3 decades of technological changes, that there is going to be change. There is going to be change in technology, there is going to be, and what is true today will not be true tomorrow. Innovation is bound to be fundamental to such change. In 2005, there was a study by MIT, Lemels in US, where among the top 25 technological changes in the world across sectors, 23 of them belong to the ICT domain. ICT domain has seen changes in technologies which like no other domain has seen. And to be able to survive in this sector, we need to innovate. Companies which are leading brands in a given year, 2 years down the line, are suddenly vanishing or struggling to exist just because there are other companies who have been able to take advantage, come up with innovative products which if you are not able to match, you find it difficult to continue. Also, another interesting linkage that has come about is that a lot of this innovation has been driven by the needs of defense, needs of strategic sectors in several countries. The desire to be able to have an edge in defense technologies has resulted in advancement of IT related technologies. Now we are talking of photonics. What is basically photonics going to do to what we do fundamentally in electronics? It makes the speed of connectivity faster and it makes energy consumption lower. With these two fundamental facts, you are able to do things more efficiently, make your devices more powerful and able to generate more in less. Now, if this fundamental technology is going to get commercialized, today we all get amazed at the size of a smartphone being able to do what a supercomputer used to do 25 years back. Think of what the next world generation could be like. And it is this revolution that we are at the cusp of. Photonics is today at the cusp of becoming the next generation of computing revolution in the world. We in the electronics sector, Department of Electronics and IT recognize that if you look at the electronics era, somewhere down the line we missed the bus. We started with Semiconductors Complex Limited in Chandigarh, where some very good work was happening, and then somehow, somewhere, we kind of did not build on that. Today, when we are recreating the whole philosophy and effort to have electronic system design, there is a conscious effort that we need to leapfrog knowledge, we need to leapfrog technologies. We can't start from where we left, and we can't possibly compress all the knowledge that people have acquired and companies have acquired and institutions have acquired over the last 20 years. And there's been humongous amount of work that has gone on. So what we really need to do is actually see what are the emerging areas of the future. What are the areas on which people are studying today, and can we join them in that level at that point of time today and take that forward. Let me give you an example of some of the work that we are doing to see that we leapfrog and join technologies, emerging technologies of the world. One such example is flexible electronics. A huge area, a new area of electronics where work is happening world over. New products have started to come. Flexible electronics is becoming more and more commercialized these days. But there is room to move along shoulder to shoulder with cutting edge work that's going on world over. And we have created a national center of flexible electronics with a consortium of institutions and industry, and it is located at IIT Kanpur. There is a similar center of excellence on security devices, which has been set up very recently at IIT Bombay. In the area of IoT, we have set up a center of excellence. There is some work going on at IISc Bangalore in nanosciences and in photonics. I think it is in these areas that we, as part of the larger ecosystem to develop electronics in the country, we are from the government side trying to promote or support. We have one of the ambitious projects that we have taken up under the electronics manufacturing is setting up of semiconductor wafer fabs. And again, Madhav mentioned about manufacturing chips. Today it remains the frontier edge technology in the domain of electronics. Very few companies today are actually able to do the latest level of chips that are required. Government of India did a global expression of interest and identified 2 consortia to set up semiconductor wafer fab. These are huge investment projects. Each fab costs about $5 billion or thereabout. And we are also finding, while we are working with this consortia, there is also realization how much of an effort is required to make a project like this happen. Now, meanwhile, we also see there is an interest for developing a photonics fab. I think that's something very interesting that needs to be looked into. The government of India has a policy which provides incentives for setting up of a fab of this nature. There are several incentives under the modified special incentive package scheme. 25% of capex is available as reimbursement of capital invested. All duties that are levied on equipment that is used for such a fab are available, are reimbursed. For a period of 10 years, there is a production subsidy of 10% on all production that is made. That is, if you are producing, let's start with an example of, let's say, 100 million investment, which yields a turnover of about 400 million every year. On 100 million investment, first of all, you get 25 million of capital subsidy. Out of this 100 million, if 50 million is capital equipment on which 10% duty is levied, 10 to 12%. Another 5 to 6 million duty is reimbursed.